All right, hello everyone, and welcome to Data Engineers Lunch number 116. Don't forget to like the video and subscribe to the channel, as well as ring the notification bell if you'd like to be notified every time we post a video or go live. Today's topic is what are semantic layers and how Dremio Semantic Layer empowers data lakehouses. We'll learn about the concept of the semantic layer and its transformative impact on data management. Alex is going to explain how a semantic layer can be utilized to define views and metrics that encapsulate your business logic, ensuring consistency and clarity across your data ecosystem. Our speaker today is Alex Merced, Senior Technical Evangelist at Dremio. The organizer of this event is Rahul Singh. If you are interested in being a co-organizer or want to help us get speakers by reaching out to people in the community, you can drop an email to us at marketing@anon.us. Data Community DC, we are part of Data Community DC, and Data Community DC believes in building an inclusive environment, so no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is itself made up of a number of different groups generally composed around data, and you can find out more about them at datacommunitydc.org or dc2.org. At Data Engineers Lunch, we cover everything involving the ingress and egress of data and everything in between. We cover databases, ETL, data wrangling, and all the tools and processes in the data engineering world. If there's anyone that's new here and would like to say hi, what brought them here, and what they hope to get out of this, you can leave a message in the YouTube chat. Remember again to like and subscribe and ring the notification bell. Our group rules: if you have a question, ask it, be polite and courteous to others, and share what you know. Here at Anon, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra, we talk about data engineers. We have a burgeoning Gen AI LLM practice to build custom chatbots and fine-tuned LLMs to help you talk to your data. We have a number of program sponsors in addition to our institutional organizational sponsors. If anyone has job offers, is looking for a job, knows about meetups, hackathons, or classes going on, feel free to drop information about those in chat as well. Data Engineers Lunch happens generally weekly at this time. We also have a Cassandra lunch that we are sort of reshuffling, revamping. Our not Cassandra runbooks are still available. If you would like to read those, you can click the link that I will be putting in chat now. All right, I will pass to our speaker for today, Alex.
Hey, everybody. Let me share my screen. And there we go. Well, hello, everybody. My name is Alex Merced, and I'm going to leave this slide up for a moment just for everyone to give a chance if they want to scan this QR code to download this slide deck and other slide decks that I do for different presentations. But yeah, no, my name is Alex Merced. I am a senior tech evangelist at Dremio. But before we get started with our today's presentation of what is a semantic layer, I want to again give you a little bit more context on who I am and where I am from. So first, let's just talk a little bit about where I'm from. So I mentioned I'm a senior tech evangelist at Dremio. What is Dremio? Well, Dremio is the unified lakehouse platform for self-service analytics. What does that mean? Well, what it means, it just makes doing more with your existing data lake much easier. Okay, easy, open, fast. It basically makes it easier to use your data lake, faster to use your data lake, and it does this through sort of 3 tiers of value through unified analytics, being able to connect not only to your data lake, whether that is S3, ADLS, whether it's an on-prem like a Hadoop or a MinIO, wherever your data lake is, but can also connect to databases like Postgres and MySQL and Mongo, and also connect to data warehouses like Snowflake, Redshift, Synapse, so that we can work with all your data in one place and curate your semantic layer, which is part of our topic today. But also Dremio has a very powerful SQL query engine that not only allows you to, which basically allows you to query data and federate queries against all those different data sources. So not only can you see your data from Dremio, but you can query your data from Dremio all in one place and govern that data, govern access to that data. And if you're moving towards an Apache Iceberg data lakehouse, so essentially basically turning your data lake into a data warehouse, giving it sort of that full-on database type functionality, Dremio can really be helpful in managing that lakehouse, taking those Apache Iceberg tables and being able to optimize them and maintain them for you automatically. So that way it really truly feels like a data warehouse-like experience. So Dremio provides tremendous value to your data lake along these lines, on top of just being sort of flexibly deployed, where you can deploy it on-prem or in the cloud, connect the data on-prem in the cloud, so that way everything is just kind of unified in one place. So knowing that I'm from Dremio, I'm a senior tech evangelist at Dremio. I've worked in the web dev spaces. I've worked in the data spaces for companies like GenEd Systems, Crossfield Digital, Campus Guard. I'm also one of the co-authors of a book called Apache Iceberg, the Definitive Guide. So I spend a lot of time talking about Apache Iceberg for those who've seen me come to the Data Engineers Lunch before. But you can get a free copy of that book, that Apache Iceberg, the Definitive Guide, by scanning this QR code. So I'll leave this up there for a few seconds for anyone who wants to download a free copy of this book. And not only can you learn more about Apache Iceberg by downloading this free book from O'Reilly, you can also register for this free course that's currently ongoing. Our next session is actually tomorrow, and you can watch all the previous sessions on demand, but basically going very in-depth into Apache Iceberg, culminating to our hands-on sessions, which will be the last 2 sessions. So basically, if you want to learn more about the data lakehouse and Iceberg and what this whole trend is, I cover a lot of that there. And we're almost done with all these, announcements. And last one, again, I host several podcasts, so you can subscribe to these podcasts over there on iTunes and Spotify. And you can find links to all of this over there at my website, alexmerced.com. All the data-specific links are at /data. But with that, now on to our featured presentation. And basically what we're going to be doing is focusing on this concept of the semantic layer. It's oftentimes, you talk to different people, you talk to 10 different people and ask people what the semantic layer is, you're going to get 10 different answers. It's one of those kind of concepts. So the goal of this is just to kind of explain sort of what it is and sort of how sort of the modeling of data evolves to deliver value. Because at the end of the day, like whatever terms you use, the end goal is to get your data set up in a way that allows you to deliver those BI dashboards, allows you to deliver that data to train an AI model, so that way you can actually serve business value, okay? Everything else in between is just the process of getting there. So knowing our agenda, we're going to be walking through the different sort of layers of data that you generally have, starting with your raw data all the way up into your semantic layer, and then generally how, like, when you think of semantic layer as a service, products that serve the semantic layer, what features do they typically have? What value propositions do they typically have? And what does Dremio offer that makes it particularly unique in that space? So generally you start off with your operational data. So bottom line, your business, your enterprise, your organization is generating data all the time. And that data could be being stored in databases. It could be being fed into like Kafka topics, as events kind of hit the system. That all that data is coming somewhere. And that data generally is going to end up in lots of different tables. So in this case, oftentimes your operational data is very normalized, right? Because if you're saving in transactional databases, you're going to want to reduce the amount of duplicative data and minimize the amount of space that it's going to take in your database system. So everything's kind of in its own normalized table. Because again, at this point, you're kind of focusing on, adding data, doing transactions, adding a record. So, some new customers registers with the platform, another order gets put in, another product gets added to the catalog. These kinds of things all sort of require their own tables. So everything's kind of broken up into lots and lots of tables, representing all sorts of the different things that can be added, that can be read, created, etc. But typically for like analytics, the more normalized the data is, you start running into performance issues because you're doing lots of joins to rejoin that data into, because basically when you start taking a look at orders, okay, you're also going to want to know, hey, who's the data of the customer? You want to know the data of the products that they ordered. So you end up doing a lot of joins to kind of really get a full view of the data you want to run analytics on. And those joins can be very processing heavy. And as the data gets bigger, those joins can take a long time. So oftentimes when you start moving towards the analytical space, you're going to be like, okay, well, now it's time to, move this data into different systems that are more columnar, because storing the data in a more columnar faster is going to be better for analytics. But also we're going to want to model the data specifically for analytics away from sort of the modeling we did for more transactional type workloads. So basically we're going to first make our bronze layer where we land the raw data as it is, oftentimes in our data lake, okay, maybe in our data warehouse. But we land this raw bronze layer where we have all these sort of denormalized tables. We haven't done any modeling yet. We haven't done really anything yet. And basically at this point, what we're going to do is we start modeling our data. Okay. And again, generally when we start landing our analytical data, our goal is to denormalize it. So we're going to start turning, this into like a sales table, and that sales table won't need to join with orders and products and customers, because we're going to have already done that and landed the data with all of that already denormalized. So that way, all those joins don't need to happen ahead of time. But the data is not perfect. There might be data that just isn't correct, data that's missing, data that's whatnot. So oftentimes we start transforming that data and trying to like curate the data. So the data is now modeled. Okay. Now we want to sit there and clean up the data. So this is going to be our like silver layer. So we're going to go in there, take a look at this table, this modeling that we've done. We want to make sure we get rid of any duplicates, check for any null values that shouldn't be null, interpolate missing data. Basically check for referential integrity. So in the case of where there might still be other tables that we would join with. So if you're doing a star schema, you may still have some other dimensional tables that you still join with, but still probably more denormalized than the original sort of transactional setup. You want to make sure that basically every reference to an ID in another table actually matches up. Okay, so again, whether you do the modeling through one big table where you just put everything in one big table, or you do like a star schema where you do layers of denormalization, but you still generally have like your fact table with all your dimensional tables sort of in one layer or multiple layers, and you start getting into like a snowflake schema. At the end of the day, you're going to want to start cleaning up that data. And that's generally what you're doing your silver layer. So at the end of the day, like it's still just the sales table, maybe the orders table and the products table. The data's clean. You verified it. You validated it. It's all clean and good. But generally it's data that serves many use cases. You can ask lots of questions of that data, but the data in itself, in its current form, doesn't automatically answer a question, any particular question. So basically, if I'm the data analyst, I would have to go think through what my question is and write the right SQL to get my particular answer. So when you're serving a BI dashboard, you generally want to just have the data that answers the specific question that dashboard is answering, or the specific data that AI model needs to be trained on. And this is where we kind of start getting into what's called the gold layer or the semantic layer. So we have our data, the data is modeled, but specifically for specific use cases, you're looking for specific pieces of data, specific metrics, okay, specific views of the data, okay? And generally these things are going to have names that mean something to business users. That's the whole term sort of semantic. The idea is that, okay, hey, we've taken sort of this very denormalized data, we've very normalized data, we've denormalized it into an analytical model. Okay, again, one big table, star schema, snowflake schema, whatever fits best for your particular needs. We've cleaned that up. We get our silver layer, so we've done a lot of cleanup and prep work. And now we're injecting our business logic. So the idea is like, hey, now there's no more cleaning to do. All the changes going forward are more to specifically answer specific questions that the business has. So the end objects that we have here are things that answer specific business questions. They give us specific numbers, aka like our business metrics, our semantic layer, because these are the things that, I'm no longer looking at sales, I'm looking at sales for July 2024. Okay, that's going to allow me to answer very specific questions as a subset of a much larger table, or sales by customer, sales by region. So you notice that each of these are sort of more answering a very specific thing. They're data sets that are derived from the total data for answering specific questions. So this is our semantic layer where we define the ones we need of these. Okay, sales by products. These are just again examples. Ideas like, okay, what is the logic I need to build the chart that I need, or to feed the model that I want to train on? Okay, so really at the end of the day, your semantic layer is essentially your gold layer. It's just where you're defining the objects for consumption, and you're defining them in a way through using terminology. So this is where we start getting into like ontologies and taxonomies, sort of using the terminology of the business, so that when people see these objects, it sort of makes sense to them. Like it's no longer, hey, abstract data modeling world. It's now my particular business using the particular terminology of the enterprise, that I kind of know which data sets I'm grabbing, because it makes sense to that business user who's not thinking in data engineering world. They're thinking in, hey, I understand the context of my business. Okay, but bottom line is that oftentimes when it comes to the semantic layer, what generally has traditionally happened is that you would build BI dashboards. And the BI tool would have some sort of semantic layer built up on it. So the idea is that you would have your data sources. This might be like your preparation, your silver layer, and then you're actually writing the SQL to create that sort of use case specific view of the data right in your BI tool. And then you would actually generate sort of a physical copy of that data using a feature called an extract, a BI extract. So basically your BI tool, whether that's Power BI or Tableau or Apache Superset, it's going to make this physical copy that only works in that tool. Okay, and that's going to speed up the dashboard because you're just creating that subset of the data. But what happens if you have multiple teams at your company working off the same data warehouse, working off the same data, but this team uses Power BI and this team uses Tableau, and each of them are creating their own extracts in those tools. So you now have two extracts of the same data, okay, especially if they're answering the same question just on different teams. And you're basically there's a cost to that. And there's also an efficiency to that, because what if those extracts, what if the way they defined that particular metric that they're both measuring, they defined it slightly differently? So what happens is that when you start having your semantic layer, your business metrics defined directly in your BI tool, okay, you run into possible consistency issues in case different teams define it differently. You run into duplicative materialization across different tools. So when it comes to a business layer service nowadays, you're starting to see sort of these decoupled products where the semantic layer is a separate product from your BI tool. So this way you have a place where you define and you create those physical copies and that cache of just those specific business metrics. But now all the BI tools can connect to it. So in this case, what happens is that you only have to define that particular metric once, and multiple teams can use it. So you're going to get more consistent definitions of those metrics. But two, you're not going to have the duplicative materialization of those metrics. So when you think of just most businesses that refer to themselves as a semantic layer, or businesses that include a semantic layer product, this is essentially the value they're providing. They're saying, hey, you know what? We're going to give you that layer, a way to create that layer that's separate from your BI tools, okay? Or from wherever you're consuming the data. So that way you can reuse those same metrics. You can define all the metrics, define all the things that are meaningful to your business, define them once that everyone can use it, and then accelerate them through materializing them, whether it's through like materialized views or through cubes or through other features. I'll talk about another feature that's a really cool way of doing it in a moment. But that's essentially what the service, the productization of the semantic layer really means. Now, Dremio is a product. It's technically a data lakehouse platform, but one of the values that it provides is a semantic layer, okay? And Dremio semantic layer is particularly unique in a lot of ways, because it's not just for sort of creating that gold layer and delivering it, but it also allows it to optimize queries across all your data, okay? Basically, because the semantic layer is sort of attached to how the Dremio query engine works, the Dremio query engine is able to look throughout is able to be aware of how different data sets are related to each other, which allows it to optimize the way it runs queries, able to optimize its caching, where basically queries on related data sets can optimize each other, which is pretty unique. So you get this really nice high performance right out of the gate just because of how the engine works, but also the way it does that sort of, instead of using materialized views and cubes, the way it's going to do that kind of acceleration can also be very unique. And we'll talk about all that. Okay, so essentially the way Dremio works is that you have all your data sources. So instead of having to move all your raw data directly into one place, you could actually have all your raw data just directly connected to Dremio. And then using Dremio semantic layer, you can then take that raw data, clean it up, so do all your preparation work in your preparation or silver layer, or however you want to call it, and then again have your gold semantic application layer delivered, and have that all modeled. And again, it can be all modeled virtually through views, okay, through sort of database like views. So you're essentially not duplicating the data, because Dremio is able to federate the queries across all these data sources quite quickly. Okay, that's not only there's other tools that can federate queries across different sources, but Dremio does it very performantly. Okay, that's not only does Dremio give you this sort of entire environment, but it's also the extent of how Dremio can do this performantly and at scale is what makes Dremio unique. Okay, so I can connect all my data sources. I can then model the data that I need for my data purposes, and then I can accelerate it. So then basically I have my gold layer, my semantic layer sort of modeled here in Dremio, and now you have the same definition of those metrics across different BI tools. So different BI tools can connect to Dremio and get the benefit of accessing the same definitions of the same data sets. When you want to accelerate it, the acceleration happens in Dremio, not in the BI tool. So you're not materializing twice. And again, the way Dremio is going to materialize will be different. So most other systems either use materialized views, where you essentially just make a copy, a physical copy of that particular sub data set of that metric data, or a cube. When you're doing aggregates, it creates essentially not a physical copy of the raw data, but a physical copy of the aggregated results. So like the mins, the maxes, based on different facts and dimensions, averages, totals, that kind of thing. Now, usually what you'd have to do in other tools is that, one, you'd have to recreate these cubes and materialized views periodically as the data changes. You have to handle how to sync them. It would create another name. So like the cube or the materialized view would essentially be a separate object than the original table. So the analyst needs to know that when they use the BI tool, don't create the BI tool on the original table, create the BI dashboard on the cube or on the materialized view. Well, with Dremio, that's going to be a little bit different. Okay. And again, just to show you sort of like how Dremio Semantic Layer works, generally when you take a look at Dremio's UI, what you do is you see these tables. So purple tables always represent physical data. So this could be a physical table in your database, a physical table in your data lake, a physical table in your data warehouse. And then what you do is you create views on it. So these are like SQL views. So these are not copies of their data. They're essentially, hey, when I query this join view C, it's essentially rerunning some SQL that I previously defined, okay, to get that specific subset of the data. So I can then now, again, continue deriving views to generate till I can get down to my sort of semantic layer into the specific views I need for specific use cases. But Dremio has a unique feature called data reflections. Now, data reflections is different than materialized views and cubes in that it takes away a lot of the heartache. So again, what are the heartaches? From the data engineer's point of view, okay, the pain with cubes and materialized views is having to manually maintain them, having to figure out how to keep them in sync, having to constantly refresh them manually, track that kind of logic and schedule that logic. Reflections do this automatically. So I say, hey, I want a reflection on this particular view here. So in this case, what it'll do is it'll make an iceberg. And the things that the reflections are not just a straight up copy, they're essentially an iceberg table. So even if the original data is not Apache iceberg tables, it'll create an iceberg table on your data lake. And the cool thing about iceberg tables is they're not just the data, but they're also this metadata that acts as an index. So you get the additional performance benefit of that metadata, that index. So it's kind of like having an index and a physical copy of the data at the same time, and accelerating from having that physical copy and an index attached to it all in sort of one go. But Dremio will automatically generate that for you, and then will automatically update it. Okay, and the cool thing is that now if a query comes in for business unit view E here, Dremio, basically, the analyst's problem usually with materialized views is that they would have to know the other name. So it wouldn't be called business unit view E anymore. It'd be like business unit view E materialized. And I'd have to make sure I update all my queries to reflect those changes. But with Dremio, since Dremio is aware that there's this reflection that was created based on business unit view E, when an analyst just runs their normal queries without being aware that this reflection exists, Dremio will automatically swap it out if it would accelerate the query. Again, Dremio will first check to see, hey, would this actually make the story better? Okay, it'll always double check and kind of optimize based on certain scenarios, depending on sort of what will result in the best and most efficient query plan. But the cool thing is, because of Dremio's semantic layer having this knowledge of how each of these things connect, if another user queries user view I here, even though user view I does not have a reflection on it, it is a child of a view that has a reflection on it. So the Dremio query engine is aware that essentially this has the data that's in here as well. So instead of rerunning this query all the way from sort of the original raw data, it can take advantage of this reflection, even though the reflection was never really intended particularly for this view, it just gets reused. So not only do you, so basically now when you're taking that acceleration that you're using to accelerate data sets, that reflection can then is reusable and gives you more bang for your buck. Okay, and that's one of the beauties of how Dremio works, is that one, it makes it really easy to accelerate and allows you to get the maximum value of that acceleration when you do it strategically. And Dremio makes that even easier because Dremio has added a auto recommendation feature that will help you identify where these reflections should be used. and actually literally give you the SQL to do it. So that way it makes the maintenance of these things and the thinking through and deciding when to use it much, much easier, because it can monitor the activity of your Dremio cluster and say, hey, these are the queries, these are the reflections that will save you money and time, improve performance, and also reduce your costs. And then, hey, you don't need these reflections anymore because you're not querying that data as much. So you can delete those reflections. It'll give you these kind of recommendations, making managing this much easier. Now, you don't have to take my word for it. If you want to see this in action, you can always just get hands-on with it. So right here, you have QR codes to several different exercises that will let you get hands-on with Dremio, with Apache Iceberg, and other data tools. This first exercise here, the intro to the iceberg, is going to be the simplest one. It just gets basically, you set up Dremio, you set up MinIO and Nessie right there on your laptop, and you start running some queries, doing creating some tables, and you can see it all in action. Now, if you want to see the whole end-to-end experience, starting from your transactional data, so data in a Postgres table or a SQL Server table or in a MongoDB collection, you can do one of these 3 other tutorials that allows you to start with that data, move it into your data lake as an Apache Iceberg table, and then deliver a BI dashboard at the end. So they're more end-to-end exercises that kind of allow you to see the full extent of everything. But you'll see that I mentioned a few things. Again, fast, easy, and those are some of the things that Dremio delivers. You'll see that, hey, like this was actually 1, fast, and 2, pretty easy. And again, when you're running Dremio off your laptop, you could still connect all these other sources of data. So you want to connect your S3, you want to go connect other databases. You can literally start fetching queries directly from your laptop if you wanted to, and then do more production style deployments once you want to scale up and try Dremio in a more holistic way. But I'm constantly speaking all over the place, physically and virtually. And I am currently running this Slack community here called the Data Lakehouse Hub, which you can join by scanning this QR code. So you can join the Slack community there. You can message me anytime. I do have meetup channels for all the major cities that I have a tendency of traveling to quite a bit. So if you're in one of these cities and want to hear about when I'll be speaking in your area sometime soon, join the Slack community and then look up these channels and join those Slack channels. And I will keep you informed on when I'm around. Another way you can do it is you can also join this calendar. By subscribing to this calendar, you'll be aware of all the events I'll be speaking at, whether virtually or in person, and also be aware of any events that my colleague, Andrew Madsen, will be speaking at as well. So you can scan this QR code, subscribe to that calendar, and never miss a future event. And with that, I think we are done with the presentation. Hopefully this helps clarify sort of a lot of things. With that, I'm going to open it up to questions. And while we answer those questions, I will leave this page on the screen. So open the questions.
All right. Thanks, Alex. We got a question in the chat that you already kind of touched on a bit. Where do you store Dremio aggregated data?
Oh, okay. So when you're using reflections, so basically when you use Dremio doesn't actually have its own store, in the sense that what it does, generally you will provide your data lake as its sort of store. So essentially when you're configuring your Dremio cluster, you'll say, okay, hey, Dremio, store data on my ADLS or on my S3 or on my MinIO. You tell it where. So that way, any reflections that it creates, so again, these Apache Iceberg tables that it'll create under the hood as a pseudo sort of materialized view, it will store them in your data lake. So it's all still under your control. And they're technically full-on Iceberg tables that you could go in there and then inspect right there in your data lake storage. But it's all done in your data lake storage. So Dremio never technically is really storing your data. The Dremio nodes, at best, they're doing some caching. There's like a feature called the columnar cloud cache that Dremio has. So the Dremio nodes, what they'll do is that if you're frequently accessing something from object storage, they'll cache maybe like a Parquet file or like a particular row group from that Parquet file, and cache that on if it's frequently read. So it'll be like, oh, okay, we've read this like 5 times. We should probably not have to keep getting this from S3 every single time. So let's just make a quick copy right here locally, and then that reduces the amount of S3 calls or amount of network calls you're making to your object storage, which also then reduces, 1, improves performance, but 2, also reduces your object storage costs, which is a really cool feature of Dremio. But that's about the extent of what the Dremio nodes will store.
Cool. And then I had a question. You had mentioned that sort of, if there are 2 teams and they're using Power BI and Tableau and they have a metric that is basically the same on the semantic layer, they're sort of replicating that work because they each have their own semantic layer. And if you're using
Mhm.
Dremio, it's combined into a single. How does that work for? You also mentioned that there are times that they could be defined slightly differently. And
Yeah.
how does Dremio sort of handle that overlap where,
Well,
you're
if you
doing
have
mostly the
two,
same analytics, but
yeah. So if you had two views of the data, one that maybe is a slightly different SQL query, I mean, and they're not necessarily, then they wouldn't necessarily be the same metric. So you would have two views in the Dremio dashboard. You would create two views with the different SQL statements. And the cool thing about Dremio is that because its user interface and security features make it pretty easy to make sure you know who has access to what. You can oftentimes give those business users and analysts access to the data a little further up. So you can give them access to the silver layer per se. So that way they can self-serve their metrics. So instead of saying, okay, hey, being a data analyst and saying, okay, hey, let me go submit the data engineering. I need this specific metric. And then what happens is that they have to create a version of it in in the data warehouse, and then the data analyst then cleans that up and then builds their extract in the BI tool. A data analyst can go directly to the silver layer, craft that specific metric they need, and not have to do this iterative process where they're constantly having to submit tickets to the data engineering to make minor changes. So everything just gets thrown. So if different people need different tweaks to their views, they are able to create custom views. And Dremio really provides a very self-service way to kind of make all your data accessible without allowing them to make physical changes to the data.
great.
Cool. But if there's no other questions, I invite everyone to constantly follow me on LinkedIn and Twitter. I'm constantly doing lots of posts and speaking in lots of different places. Thank you to Anat, as always, for having me here on the Data Engineers Lunch, and I'll see you all around. Thank you very much.
All right. Yeah. Thanks for another great talk.
Thank you.
Okay. Stream is ended on YouTube.